Welcome back. So today we are going to discuss electric dipole. So in previous video we are going to discuss electric dipole. So this is the most important topic in this chapter. So electric dipole. So once remember that. So what is electric dipole? So two equal and opposite charges are separated by the small distance. So that is called the electric dipole. So we know that. So two equal and opposite charges. So this is one is minus 2 charge, so other one is plus 2 charge. These two charges are separated by a small distance. So the distance is 2a. 2a is the distance between the two charges. So this is called the electric dipole. So here, so O is the center of the dipole. Center of the dipole to minus 2 charge is a. So center of the dipole to plus 2 charge distance is a. So every dipole having the dipole moment, you know that. So dipole moment is denoted by P. So what is the definition of dipole moment? The product of any one of the charge at certain distance. So the product of any one charge. So either positive or negative. Now if we take the only magnitude of the charge and certain distance. So this is the dipole moment. So this is very important. So every dipole having the dipole moment. So the product of magnitude of any one of the charge and the distance. So whose direction? So this is the important. So whose direction along from minus charge to plus 2. So that means so minus 2 to plus 2. So this is the direction of the dipole moment. So negative to positive. So this is very important. So now, so in this electric dipole working on two types. So one is axial line. So other one is equatorial line. So these two questions are very important in our board questions, board exams. So board exams only, the two questions very important. So these questions are given 5 marks questions. Okay, so 5 marks questions when came to. So one is axial line, other one is equatorial line. These two questions are very important in this chapter. So understand this each and every question. So must and should. Okay. So axial line and then equatorial line. For example. So this is the dipole minus q. This is plus q. So these two charges are separated by the distance 2a. So now find out the magnetic field. So for example, this is the point P. So in this point P, we want to find out the electric field. So here, so this is the dipole. So P point, where is the P point? P point around the dipole axis. So P point around the dipole axis. So this line is known as the axial line. Axial line. So here theta is equal to 0. So P is the axial line. So P, where is the P point? Along the dipole axis. Along the dipole axis, mere now intensity of the electric field is find out. So that line is known as the axial line. So axial line along the dipole axis. So axial line along the dipole axis. This is the axial line. So what is the angle theta equal to 0 degree? So theta equal to 0. So this is axial line. So along the dipole axis. So next is equatorial line. So this is minus 2 charge. So this is plus 2 charge. These two charges are separated by the distance 2a. So O is the center of the dipole. So this is the point P. So here P is the point P. So now we want to find out the intensity of the electric field at point P. So this point P is at a distance smaller from the center of the dipole. Center of the dipole. So this is perpendicular bisector. So perpendicular bisector. So perpendicular bisector or equatorial line. So equatorial line. So both are same. So your angle is theta is equal to 90 degrees. So this is the equatorial line. So equatorial line is perpendicular to the dipole axis. So in the dipole, so P point are there. So perpendicular line. So where is the P point? Perpendicular to the dipole axis. Perpendicular to the dipole. So this is the equatorial line or perpendicular bisector. So where is the P point along the dipole axis? So this is called axial. So here where is the P point? Perpendicular to the dipole. perpendicular to the dipole. So this is called perpendicular bisector equatorial line. So axial line or end on position. This is end on position. So end on position. This is end on position. So these two questions are very important. Keep on your mind. So understand first of all. Okay. So one is axial line where intensity of the electric field find the point. So equatorial line where intensity of the electric field find the point. So these two questions are very important for our board exams. So 5 marks questions. So very important. Okay. So very important. So now we shall discuss one by one question. So here it is clear that so where is axial line? Axial line along the line. What is equatorial line? So P is a point. So where is the P point perpendicular to the dipole? So one is along the dipole, other one is perpendicular to dipole. So along the dipole ಮೇಲೆ ನಾವು intensity of the electric field ಅನ್ನು find out ಮಾಡಿದರೆ that is the axial line. So perpendicular to the dipole ಮೇಲೆ ನಾವು intensity of the electric field ಅನ್ನು find out ಮಾಡಿದರೆ that is called the equatorial line or perpendicular bisector. Okay. So these two questions are very important. So now we shall discuss one by one. First of all, so what is the question? So derive an expression for, so the expressions are very important. Keep on your mind. Derive an expression for intensity of the electric field. So due to an axial line of electric dipole. So an axial line of electric dipole. An axial line of electric dipole. So intensity of electric field. So intensity of electric field. Intensity of electric field due to intensity of electric field due to an axial line of electric dipole. So this is the end on position. This is very important. So in question you solve ಮಾಡಕ್ಕೆ ಮುಂಚೆ so once remember so isolated due to point charge. So briefly discuss we have already discussed in previous videos. So this is one charge, so this is source charge. Okay. So here now, so this is the point P. So for example, this is the point P. So is at a distance smaller. So P in the Q1 charge distance or distance. So here now if we take the test charge Q1, okay, now if we take the test charge Q1. So here intensity of the electric field due to at point P. Intensity of electric field at point P due to plus Q charge. So what is the formula for the intensity of the electric field due to point charge? So 1 by 4 pi epsilon naught 2 by r square. So this is very important formula. So this formula is used for in these two questions. Okay. So intensity of the electric field at a point P due to charge. So here 1 by 4 pi epsilon naught 2 by 2 square 2 by r square. So intensity of the electric field depends upon only source charge, does not depends upon the test charge. So we know that we are already discussing previous videos. So once recall that videos. So once see that videos. So E is equal to 1 by 4 pi epsilon naught 2 by r square. So this is the formula for intensity of the electric field due to isolated point charge. So this formula used to solve these two questions. Very important formula. So now if we take the electric dipole, so we know that what is electric dipole? Two equal and opposite charges are separated by the certain distance. So now if we take the minus Q charge, so next one, so if we take the positive charge, so these two charges are separated by the distances to A. So first of all, understand the diagram. So this is very important. Once understand the diagram, you can solve easily. Okay. So diagram ಅರ್ಥ ಇಲ್ಲ ಅಂದ್ರೆ so ನೀವು ಈಜಿగా ಸಾಲ್ವ್ ಮಾಡಬಹುದು. So diagram ಅಂದ್ರೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಟ್ರೈ ಮಾಡಿ. Okay. So first of all, two charges separated by the certain distance to A. So this is the electric dipole. So here O. So O is the center of the dipole. So center of the dipole to charge. So what is the distance? Distance A. Center of the dipole to plus Q charge. What is the distance A? So this is distance A. So here also distance A. Okay. So now find out the, we want to find out the intensity of the electric field at point P. So this point P is along the axis of the dipole. So here, so this is the dipole axis. So now if we take the point P, so some distance. So this is point P. Okay, this is point P along the dipole axis. So along the dipole axis. Okay, so this is point P. So in this point P, is that the distance smaller from the center of the dipole? So very important. So where is point P? So point P is that the distance smaller from the center of the dipole. So center of the dipole with the smaller distance ನಲ್ಲಿ P ಅనే point ಇದೆ. Okay. So ಅರ್ಥ ಆಯ್ತಲ್ಲ? Okay. So here two charges separated by certain distance. So O is the center of the dipole. Center of the dipole to minus Q charge ಎಷ್ಟು ದೂರ ಐತಿ Q. Center of the dipole to plus Q ಎಷ್ಟು ದೂರ ಐತಿ Q. So now P is a point along the axis of the dipole. So this is axial line. This is axial line. So P is a point. Let P be a point on the axial line of the electric dipole. Is the distance smaller from the center of the dipole. So we already discussed. We know that. So dipole having the dipole moment. So this is the dipole. So having the dipole moment. So what is the formula for dipole moment? P is equal to any one charge into certain distance. Any one charge into certain distance. So P is equal to Q into 2A. So this is dipole moment. So next one. So here, so we want to find out the intensity of the electric field at point P due to minus Q charge and plus Q charge. So due to minus Q charge and plus Q charge. So now here, so E1 is equal to, so intensity of the electric field at point P due to minus Q charge. So first of all, calculate the intensity of the electric field. So intensity of the electric field at point P due to minus Q charge. So in next one, intensity of the electric field at point P due to plus Q charge. Okay. So first of all, so you know that intensity of the electric field due to isolated point charge. What is the formula for intensity of the electric field isolated point charge? E is equal to 1 by 4 by epsilon naught Q by R square. So here P is a point in that distance smaller from the center of the dipole. Okay. So next one. So what is the distance between plus Q to P? So now we can calculate this distance. So this is very important. So plus Q charge is the P point S1. So first of all, calculate this. So center of the dipole to P charge. So what is the distance? Small. So center of the dipole to P. So what is the distance? Smaller. So next, center of the dipole to plus Q charge. So what is the distance? A. Okay. First of all, understand this point. So center of the dipole to P point. So what is the distance? Smaller. So next, center of the dipole to plus Q charge. What is the distance? Q. So now calculate the distance between Q and P. So this distance minus this distance. That means smaller minus A. So what is the distance between plus Q to P? Smaller minus A. So this is the distance between plus Q to P. Okay. So center of the dipole to P point. So what is the distance R? Center of the dipole to Q charge. What is the distance here? So now calculate the distance between Q and P. So in this distance is R minus A. So E distance minus A distance. So therefore E distance. So this is R minus A. So next one. So calculate the distance between minus Q to P. Okay. So minus Q to P. So here center of the dipole to P. So what is the distance? R. Center of the dipole to minus Q distance is to A. Okay. So here next calculate the distance between minus Q to P. Minus Q to P. So E distance add ಮಾಡೋದಾ? Okay. So E distance ಇಂದ E distance ನಾವು subtract ಮಾಡಿದಕ್ಕೋಸ್ಕರ E distance ಬಂತು. Okay. So R minus A is equal to QP distance. So next calculate the minus Q to P distance. So here center of the dipole to P R, center of the dipole to minus Q is A. So therefore, so total distance is R minus A. So R plus A. So this is the distance between minus Q plus A. So E distance add ಮಾಡಿದ್ರೆ total distance. Okay. So this is the very important. So plus q to p distance ಎಷ್ಟು ಈಗ r minus e minus q to p distance ಎಷ್ಟು r plus e. So now we want to find out the intensity of the electric field at point p due to so minus q charge and also due to plus q charge. So here first of all E1, so E1 is equal to so intensity of electric field intensity of electric field intensity of electric field due to minus q charge. Under minus q charge use ಮಾಡಿ p ಅనే ಪಾಯಿಂಟ್ ಅಂತ ನಾವು intensity of electric field find out ಮಾಡ್ತೀವಿ. So what is the value of E1? So that is value of E1. So next E2. So E2 is equal to intensity of electric field. Intensity of electric field due to plus q charge. Intensity of electric field due to plus q charge. So E charge use ಮಾಡಿ p ಅనే ಪಾಯಿಂಟ್ ಹತ್ರ intensity of the electric field find out ಮಾಡಿ. So what is the value of E1? So that is value of E1. So next plus q charge. So plus q charge use ಮಾಡಿ p ಅనే ಪಾಯಿಂಟ್ ಹತ್ರ ನಾವು intensity of the electric field find out ಮಾಡಿ. So that is called the E2. So we know that so intensity of the electric field అనేది positive charge ಅನ್ನು ನಾವು ಯೂಸ್ ಮಾಡಿದ್ರೆ intensity of the electric field is away from the positive charge. So ಅದೇ ನಾವು negative charge ಅನ್ನು ಯೂಸ್ ಮಾಡಿದ್ರೆ intensity of the electric field is towards the negative charge. So this is very important. So positive charge use ಮಾಡಿದ ಟೈಮಲ್ಲಿ intensity of the electric field is away from the positive charge. So negative charge use ಮಾಡಿದ ಟೈಮಲ್ಲಿ intensity of the electric field is towards the negative charge. So here, so E1 value calculate ಮಾಡೋಣ. So next E2 value. So first of all we can calculate E1 value. So intensity of the electric field at point P due to minus q charge. Okay. So ಈಗ ಏನಿದೆ ಫಾರ್ಮುಲಾ E is equal to 1 by 4 pi epsilon naught q by r square. R is the distance between point P to q charge. Okay. So this is keep on your mind. So you first of all calculate the E1 value. So this is intensity of the electric field at point P due to minus q. So at point P due to minus q. So here also at point P due to minus q. Okay. So here minus q. So intensity of the electric field at point P due to minus q. So this is E1. So here negative charge is there. Intensity of the electric field is towards the charge. So this is the value of E1. So why? Because so now if you take the negative charge, so negative charge is use ಮಾಡಿದ್ರೆ intensity of the electric field is towards the charge. So in what direction represents intensity of the electric field? So towards the charge. Okay. So this is value of E1. So intensity of the electric field at point P due to minus q charge. This is E1. So E1 is in the direction of the towards the negative charge. Okay. So next one. So intensity of the electric field at point P due to plus q charge. So now ಈಗ A charge use ಮಾಡ್ತಾ ಇದೆ plus q charge. So plus q charge ಇದೆ ಅಂದ್ರೆ intensity of the electric field is away from the positive charge. So in what direction? So in this direction, away from the positive charge. So these 2 points are very important. So one is intensity of the electric field at point P due to minus q charge. The intensity of the electric field is towards the charge because of so now I am using the negative charge. So now negative charge use ಮಾಡಿದಕ್ಕೋಸ್ಕರ intensity of the electric field is towards the negative charge. So next one, so intensity of the electric field at point P due to positive charge. So intensity of the electric field at point P due to positive charge, then the intensity of the electric field is away from the positive charge. So this is E2. Okay. So now calculate E1 and E2 values by using this formula. Okay. So this is very important formula. So what is the formula for E? E is equal to 1 by 4 pi epsilon naught q by r square. So r is the distance from point P to charge. Okay. So ಈಗ ನೋಡಿ. So minus q ಇಂದ p ಅనే ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ? r plus a distance. Okay. So minus q ಇಂದ p ಅನೇ ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ? r plus a. So at the same time, so plus q charge ಇಂದ p ಅನೇ ಪಾಯಿಂಟ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ? r minus a. ಈಗ ನಾವು ಡಿಸ್ಟೆನ್ಸ್ ಯೂಸ್ ಮಾಡೋ ಟೈಮ್ ಅಲ್ಲಿ r plus a and r minus a ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay. So from charge to point P. So what is the distance? From charge to point P. What is the distance? Okay. Is clear? So next, so calculate the E1 and E2 value. So first of all, calculate the E1 value. So So E1 is equal to intensity of the electric field at point P due to minus Q. So E1 is equal to, so by using this formula, so 1 by 4 pi epsilon naught Q by R square. So now if you use this formula, so intensity of the electric field at point P due to minus Q charge similar to the formula 1 by 4 pi epsilon naught Q. So here minus Q. Now if we take the minus Q, if we take the charge is positive. Now if you use the magnitude, positive sign and negative sign is represents the nature of the electric field. Okay, so positive charge is away from the electric field is away from the charge. Negative charge is electric field is towards the charge. So here charge Q. So here also Q divided by R square. R square is the distance between charge to P point. So minus Q to P point. What is the distance? R plus A. Okay, other than so R plus A distance null is there. Okay, now substitute the R plus A whole square. So this is the E1 value. Okay, so E1 is equal to 1 by 4 pi epsilon naught divided by R plus A whole square by using this formula. So intensity of the electric field due to isolated point charge. So now calculate the intensity of the electric field at point P due to minus Q charge. So what is the value of electric field? E1 is equal to 1 by 4 pi epsilon naught by R plus A whole square. So in what direction represents the E1? Along PO. So E direction. Along PO. So this is important. Along PO. So PO direction. Same E direction. Okay. So similar by applicable for the 1 by 4 pi epsilon naught. So here Q. So now here minus Q. Minus Q is plus Q because the sign is represents the nature of the field. Okay. So next one. So 1 by 4 pi epsilon naught Q divided by. So minus Q in the PNA point is R plus A. So R plus A whole square. So this is the value of E1. So next one. Calculate the E2 value. So what is E2? Intensity of the electric field at point P due to minus Q charge. Due to minus Q charge. So intensity of the electric field at point P due to plus Q charge. Okay. So here, so same formula by using the same formula, E is equal to 1 by 4 pi epsilon naught Q by R square. So it's equal to E2 is equal to 1 by 4 pi epsilon naught. So positive charge Q. So what is the distance between plus Q to P? So here R minus A. Okay. So what is the distance between plus Q to P? R minus A distance. Okay. So now if we take the R minus A whole square. So here R plus A minus Q to plus P distance is to R plus A. So minus plus Q to P distance is to R minus A. So minus Q to P R plus A plus Q to P R minus A. So 1 by 4 pi epsilon naught Q by R minus A whole square. So in what direction represents into? So along both. So positive charge is away from the positive charge. So here along OP. So along OP. Okay, so here E1, E2 value now calculate now. So next find out the E value. So E means so resultant of the electric field at point P. So here the resultant అనేది find out ಮಾಡಬಹುದಾ? So one is E direction. So E1 along the PO direction, E2 along OP direction. So now calculate the intensity of the electric field at point P. So this is the resultant electric field at point P. So next calculate the intensity of the electric field at point P, that is resultant. So next, so intensity of electric field. So intensity of electric field, intensity of electric field at point P. So therefore, E is equal to, so E is equal to, so E is equal to E2 minus E1. So therefore, E is equal to E2 minus E1. So why? Because E2 is greater than E1. So E2 intensity of the electric field at point P due to plus Q charge is greater than the intensity of the electric field. So intensity of the electric field at point P due to minus Q charge. So therefore, so E2 is greater than E1. the resultant electric field E is equal to E2 minus E1. So because of E2 is more than E1, so therefore the resultant electric field at point P is E. So now calculate the E value by using E is equal to E2 minus E1. So now substitute the values. So E is equal to, so what is the value of E2? So E2 is equal to 1 by 4 pi epsilon naught Q by R minus A whole square. So 1 by, so 4 pi epsilon naught Q divided by, so R minus A whole square. So next minus 1 by 4 pi epsilon naught Q divided by, so R plus A whole square. R plus A whole square. So this is the value of, okay. So E is equal to E2 minus E1. So 1 by 4 pi epsilon naught. So Q divided by R minus A whole square minus, so 1 by 4 pi epsilon naught Q divided by R plus A whole square. So it is clear that, so in this term Q divided by 1 by 4 pi epsilon naught is, so E term 1 Q divided by 1 by 4 pi epsilon naught. So this is the common factor. So therefore E is equal to, so Q divided by, so 4 pi epsilon naught is common factor. So Q divided by 4 pi epsilon naught is common. So next one, so here remaining value is 1 upon R minus A whole square. So 1 by R minus A whole square. So here Q by 4 pi epsilon naught is the one. So here also Q by 4 pi epsilon naught is. So Q by 4 pi epsilon naught is not common one. So remaining values remain without 1 by R minus A whole square. So here minus 1 by R plus A whole square. Okay. So here. So Q by 4 pi epsilon naught into 1 by R minus A whole square minus 1 by R plus A whole square. So is equal to Q by 4 pi epsilon naught into, so what is the LCM? So by using this to R minus A whole square into R plus A whole square. So this is the LCM. So R minus A whole square into R plus A whole square is the LCM. So now R minus A whole square here, R minus A whole square is cancelled. So remaining R plus A whole square. R plus A whole square into 1, R plus A whole square. So next one R plus A whole square. So next minus of important. So here minus of. So here R plus A whole square. Here R plus A whole square cancel. So remaining value will be R minus A whole square into 1. R minus A whole square. Okay. So here LCM is R minus A whole square into R plus A whole square. So next R plus A whole square minus R minus A whole square. So next one. So simplification of that equation. So next. So E is equal to Q by 4 pi epsilon naught. So here A square B square. So that means AB whole square by both. So here A square B square is equal to, so AB whole square. Okay. So now denominator is, so R minus A into, so R plus A. So this is whole square. So A square B square. So A square B square is as AB whole square. So next one. So here simplify this equation. R plus A whole square is similar to A plus B whole square. So we know that A plus B whole square is equal to A square plus B square plus 2AB. Okay. So by using that formula, so R square plus A square plus 2AR, so minus of, so here R minus A whole square. So by using A minus B whole square. So by using A minus B whole square formula, so we know that A minus B whole square is equal to A square plus B square minus 2AB. So now we substitute the R square plus A square minus 2AR. Okay. So this is the A minus B whole square. In next one, so E is equal to Q by 4 pi epsilon naught into, so here denominator A plus B into A minus B. So we know that A plus B into A minus B, it can be written as A square minus B square. Okay, so A plus B into A minus B, or A minus B into A plus B. So here A plus B into A minus B can be written as A square minus B square. So now in this equation it can be written as R square minus A square whole square. So R square minus A square whole square. So now by using this one, R square plus A square plus 2AR, R square plus A square plus 2AR. So multiplied by the minus, so minus R square. So minus into plus minus A square. So next minus into minus plus 2AR. Okay. So R square plus A square plus 2AR minus R square minus A square plus 2AR. So it is clear. So here plus R square, here minus R square. So plus R square minus R square is cancelled. Okay. So next plus A square minus A square is also cancelled. So remaining value is 2AR plus 2AR. So 2AR plus 2AR is equal to 4AR. So next one. So therefore Q is equal to, so E is equal to, so here Q by 4 pi epsilon naught given first. So Q by 4 pi epsilon naught. So remaining value anything. So R square A square here minus R square A square cancel. Okay, it is clear. So remaining value is 2AR plus 2AR is equal to 4AR upon, so denominator is value R square minus A square whole square. Okay, so next one now. So in this equation, so 4A, so 4A it can be written as Q into 2A. So Q into 2A divided by 4 pi epsilon naught. So already now in 2A use model, so remaining value is 2A. So here 2AR divided by R square minus A square whole square. R square minus A square whole square. So it is understand. So Q by 4 pi epsilon naught 4AR divided by R square minus A square whole square. So now as is Q by 4 pi epsilon naught 4A, it can be written as 2A into 2A. So now if you take 1 2A, Q into 2A upon 4 pi epsilon naught, already now 2A is what equals remaining 2A. So 2A R divided by R square minus A square whole square. So next one. So we know that. So dipole having dipole moment. So what is the value of dipole moment? P is equal to Q into 2A. So P is equal to Q into 2A. So next one. So E is equal to, so E value is P equal. So P divided by, so 4 pi epsilon naught. So here 2AR divided by R square minus A square whole square. Okay, so this is E. So here E is equal to ST value, E is equal to P divided by 4 pi epsilon naught 2AR divided by R square minus A square whole square. Okay, so now, so center of the dipole to P point is to R. Center of the dipole to P point is to R. So you now P point you use one. Our R value will increase. Next you use one. R value increase. Next you use one. R value increase. So next you use one. R value will increase. So R value is very greater than the A value. So because of A is very small. So compared to R. So by using that condition, so if so R is very greater than A. So therefore A square can be neglected. So A square can be neglected. A square can be neglected means A square tends to 0. A square tends to 0. So here P value. So by using P point, now use multiples for R. Now you use one. Our R value is just. Next you use one. R value increase. Next you use one. R value increase. So compared to A value, so A value is very small compared to R. So therefore, R is very greater than A. Therefore, A square can be neglected in the denominator. So in denominator, A square value now neglect one. And A square tends to 0. So next equation is E is equal to 1 by 4 pi epsilon naught. So here 2AR. So this is P. P into so otherwise P by 4 pi epsilon naught 2ar divided by ಈಗ a square value ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ವಿ because of a square tends to 0 so remaining r square whole square so ಈ ಪಾಯಿಂಟ್ ಅರ್ಥ ಇದೆ so if r is very greater than a so a square can be neglected so center of the dipole to p point distance ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ compared to center of the dipole to any one charge so a is very small compared to r so therefore if is a square can be neglected so that means a square tends to 0 so a square tends to 0 substitute in this equation so e is equal to p by 4 pi epsilon naught 2a r by r square whole square so here e is equal to p by 4 pi epsilon naught 2p r divided by r to the power of 4 r square whole square is equal to r to the power of 4 so here r gets cancelled so therefore for the final resultant of the electric field at point P so E is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught so this is AR 1 by 4 pi epsilon naught so 2p 2a already ನಾವು ಯೂಸ್ ಮಾಡಿಸ್ಕೋಸ್ಕರ q is 2a this is 2r so this is 2r here also 2r so 2r divided by r square minus l square because of 4a and a ನಾವು ಯೂಸ್ ಮಾಡಿಸ್ಕೋಸ್ಕರ remaining 2r so here also 2r so next one so e is equal to 1 by 4 pi epsilon naught 2pr divided by r square whole square okay so 4a can be written as 2a into 2a now we use for x in 2r by r square minus a square whole square 2r by r square minus a square whole square so here e is equal to 1 by 4 pi epsilon naught 2pr divided by r to the power of 4 so here are cancelled. So remaining value is 1 by 4 pi epsilon naught 2p divided by r cube. So this is the final equation. So very important. So E is equal to 1 by 4 pi epsilon naught 2p by r cube. So this is the resultant of electric field at point P due to minus q charge and plus q charge. Okay. So therefore this is the expression for intensity of electric field due to an axial line of electric dipole. So in what direction is the resultant intensity of the electric field? So we know that so here E2 is greater than E1. E2 is greater than E1. So therefore the resultant electric field direction is along the dipole axis. So this is the higher value, this is the lower value. So therefore E2 minus E1 is equal to E. So in what direction represents the resultant electric field along the dipole axis? That means along OP direction. So this is along OP. This is along OP. Therefore direction is along the dipole axis. So this is very important. Must have written this sentence. So resultant electric field in what direction? So along the direction of the dipole axis. So we know that. So in what direction happens the dipole movement? So negative to positive. So this is negative to positive. So this is p bar. So p bar direction is negative to positive. So resultant intensity of the electric field direction is also same direction, negative to positive. So therefore direction is along the dipole axis. Resultant electric field direction is along the dipole axis. So this is the resultant direction. It's very important. Okay. So this is the expression for intensity of the electric field due to an axial line of electric dipole. So very important. So what is the final equation? E is equal to 1 by 4 pi epsilon naught 2p divided by r cube. So in what direction represents the resultant of the electric field? Along OP. So that means along the dipole axis. So very important question is 5 marks. So keep on your mind. So understand this one. Okay. So this diagram is very very important. Once understand the diagram, it can be simplified easy. Okay. So next one. See next question. Question 2. So intensity of the electric field due to an equatorial line of electric dipole. Equatorial line. So this is axial. So axial line of electric dipole. What is the resultant? E is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into 2p divided by r cube. So here if we take the short dipole, so that means R is very very greater than A means. So now if we take the short dipole. So next question. So this is also very very important. So intensity of electric field. Intensity of electric field due to an equatorial line. So equatorial line means perpendicular bisector. So perpendicular bisector. Equatorial line of an electric dipole. So this is also one of the most important question. Okay, so I am already said. So these two questions are very very important in board exam. So this is also given 5 marks question. So axial line question, equatorial line question are very very important. Okay, so already completed in axial line. So next we should start with equatorial line. So we know that equatorial line is perpendicular bisector. So now if we take the electric dipole, so minus q charge. So here plus q charge. A system of two equal and opposite charges are separated by this certain distance. So what is the distance between minus q to plus q? So this is 2a distance. Okay. So O is the center of the dipole. So this is O is the center of the dipole. Center of the dipole to minus q. So what is the distance A? Center of the dipole to plus q. What is the distance A? So next one. So this is minus q. So this is plus q. So these two charges are separated by the certain distance. So this is 2a. So 2a. So O is the center of the dipole. So O is center of dipole. Center of dipole to minus q. So A. Center of the dipole to plus q. So A. So now if we take the P points, so let P be a point. So E is at distance small r from the center of the dipole. So center of the dipole and the small r distance nani P and a point. Okay. So we know that every dipole having the dipole moment. So dipole moment P is equal to Q into A. So P is equal to Q into 2. Okay. So now find out the intensity of the electric field at point P is at a distance small r from the center of the dipole. So we know that. So by using the intensity of the electric field into point charge, so we know that what is the formula 1 by 4 pi epsilon naught q by r square. So by using this one. Okay. So here intensity of the electric field at point P due to minus q charge, similar. So intensity of the electric field at point P due to positive charge. So axial line ಮೇಲೆ same ತರನೇ ಮಾಡೋಣ. So intensity of the electric field at point P due to minus q charge. So next one, intensity of the electric field at point P due to positive charge. So here also same like that. So now find out the intensity of the electric field at point P. So due to minus q charge. So next one, intensity of the electric field at point P due to positive charge. So here negative charge ಅಂತ ನಾವು ಯೂಸ್ ಮಾಡಿದ್ರೆ intensity of the electric field is towards the charge. Positive charge ಅಂತ ನಾವು ಯೂಸ್ ಮಾಡಿದ್ರೆ intensity of the electric field is away from the charge. So here intensity of the electric field at point P due to negative charge. So this is the one. Okay. So this is negative charge. So in what direction? So towards the charge. So this is E1. So this is E1. So E1 का नाम use. So next, intensity of the electric field at point P due to positive charge. So this is away from the charge. So like this. So this is it. Okay, is it clear? Okay. Intensity of the electric field at point P due to minus Q charge. Okay, so this one. So this is E1. So what is this one? E1. So this is E1. Okay. So next, intensity of the electric field at point P due to positive charge, away from the positive charge. Okay. So is it clear? So this is A. So this is R. So this is the perpendicular. So bisector. So perpendicular bisector. So here this is A. So this is point B. So now if we take the AOP, so triangle AOP now using. So triangle AOP. So triangle AOP. So now calculate the distance between AP. So next distance between the distance between AP and BP value better because of by 2 pi by 1 by 4 by epsilon naught q by r square. So AP square distance better. So here triangle AOP by applying the Pythagoras theorem. So this is perpendicular. This is also perpendicular. This is hypotenuse. Hypotenuse. So this is angle theta. So this is angle theta. So this is opposite adjacent. This is hypotenuse. Okay. So here theta is the opposite adjacent side. So this is hypotenuse. So hypotenuse square. So that means AP square is equal to. So OP square plus OA square. So OP square plus OA square. So understand first of all this. So here triangle AOP by using this right angle triangle by applying the Pythagoras theorem. So hypotenuse square is equal to opposite square plus adjacent square. So now calculate the AP square. So AP square is equal to OP. So what is the distance between O to P? R. So OP square means R square. So this is R square plus OA. So OA distance estimate A. So this is A square. So this is the value of AP square. So AP square is equal to R square plus A square. So now what is the distance between AP? So AP is equal to R square plus A square. So this is the value of AP. Okay. So AP is equal to R square plus A square. So next calculate the BP value. So now calculate the BP. Okay. So the AP value is there. So now using AP is equal to square root of R square plus A square. So this is the square root of R square plus A square. So AP square value there is R square plus A square. So now value the AP. So AP is equal to square root of R square plus A square. So the distance between A to P is R square plus A square. So next calculate the BP value. So here also same by using the right angle triangle. So here distance are here distance A. So what is the distance between BP? So here also same square root of R square plus A square. R square plus A square. Okay. So next one. So calculate the intensity of the electric field at point P due to minus Q charge. So that is E1. So E1 value calculate one. Next E2 value calculate. So first of all calculate the E1 value. So what is E1? Intensity of the electric field at point P due to minus Q charge. So by using the formula, so 1 by 4 pi epsilon naught Q by R square. So here by using that one. So 1 by 4 pi epsilon naught Q divided by. So AP square distance between minus Q to P is AP square. So AP square is equal to what is the value? R square plus A square. So R square plus A square. So in what direction represents along PA? So P direction of that. So this is along PA. Along PA. Okay. So next calculate the E2. So E2 value calculate. So intensity of the electric field at point P due to positive charge. Intensity of the electric field at point P due to positive charge in this direction. So E2 is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q divided by BP square. So distance square R square BP square. So square root cancel agade finally R square plus A square. R square plus A square. In what direction? Along BP. along so it is clear. So what is the value of E1? Once observe this two. So 1 by 4 by epsilon naught q by r square plus s square is the. So E2 value is 1 by 4 by epsilon naught q by r square plus s square is the. So these two are equal magnitudes. So here also 1 by 4 by epsilon naught q by r square. Here also same. So these two are equal magnitude but different directions. But different. So one is along PA, other one is along BP. So the magnitude of E1 is equal to magnitude of E2 is same. So this is equal to E. Okay. So magnitude of E1 is equal to magnitude of E2 is equal to E. So magnitudes are same, but different directions. One is along PA, other one is along BP. So now, so here, so this is the AP axis. So this is dipole. So this axis it makes an angle theta. So we know that path of projection is parabola. U it makes an angle theta with the horizontal. It can be resolved into two components. So one is horizontal component, other one is vertical component. So here E1. So this is E1. So this angle it makes an angle theta with the horizontal. So it can be resolved into two components. So E1, so it can be resolved into two components. So one is E1 cos theta, other one is E2 sin theta. So one is E1 cos theta, other one is E2 sin theta. So E1 it makes an angle theta with the horizontal. It can be resolved into two components. One is E1 cos theta. So E1 cos theta is the horizontal component. So this is horizontal. So what is the value? E1 cos theta. Okay. So E1 cos theta acting in this direction. So next other one is E1 sin theta. So this is E1 sin theta. So understand this one. So E1 it makes an angle theta with the horizontal. It can resolve two components. So we already discussed vector chapter. So A1 is a vector which makes an angle theta with the horizontal. It can result in two components. One is A cos theta, other one is A sin theta. A cos theta is the horizontal component. A sin theta is the vertical component. So here E1 cos theta is the horizontal. Okay, this is horizontal. So if it is horizontal, so E1, so it makes an angle theta. So this is the angle theta. Okay, so E1 it makes an angle theta with the horizontal. So E1 it makes an angle theta with the horizontal. It can result two components. One is E1 cos theta, other one is E1 sin theta. Okay, so E1 cos theta, E1 sin theta. So next E2. So this is E2. So this is horizontal. So E2 which makes an angle theta with the horizontal. So this is horizontal. So this is E2. So E2 which makes an angle theta with the horizontal. So it can be resolved into same. So two components. One is E2 cos theta. Other one is E2 sin theta. So this is very important. Okay. So E1 which makes an angle theta with the horizontal. Here angle theta and here also angle theta. Okay, so angle theta is the angle of theta. Okay, so here E1 which makes an angle theta with the horizontal. One is E1 cos theta, other one is E1 sin theta. So next E2 which makes an angle theta with the horizontal. So E2 cos theta, E2 sin theta. So E2 cos theta acting horizontally. So this is E2 cos theta. So next E2 sin theta acting vertically. So this is E2 sin theta. Okay, so E1 cos theta acting horizontally, E2 sin theta acting vertically. So in this point it is clear. So horizontal components ಏನೇನಿದಾವು E1 cos theta ಇದೆ, E2 cos theta ಇದೆ. Vertical components ಏನೇನಿದಾವು E2 sin theta acting vertically upwards, E1 sin theta acting vertically downwards. So it is clear. So at point P, so vertical components are equal magnitude because of E1 is equal to E2 is equal to EM. So same magnitude, but are in opposite direction. They can be cancelled to each other. So these two are cancelled to each other. Why? Because these two are equal magnitude but are in opposite direction. They can be cancelled out. They can be cancelled out. So only responsible for intensity of the electric field at point P is horizontal components. So that is E1 cos theta, other one is E2 sin theta. So one is E1 cos theta, other one is E2 sin theta. So therefore here E1 is equal to E2 is equal to E is equal to 1 by 4 pi epsilon naught 2 divided by R square plus A square. So these two are cancelled out, only responsible for the horizontal component. So horizontal component is responsible for the resultant intensity of the electric field at point P. So therefore, so E is equal to, so why? Because these two are acting in same direction. E1 cos theta is acting horizontal, E2 cos theta is acting horizontal. So they can be added up. So both are equal and opposite. They can be cancelled. So here we add one, here we cancel. So therefore, resultant electric field at point P is, so E1 cos theta plus E2 cos theta. Okay, E1 cos theta plus E2 cos theta. So E1 is equal to E2 is equal to E. So therefore, E is equal to E1 is equal to E2 is equal to. So E1 I use one equal magnitudes. So this is 2E cos theta. 2E cos theta. So now calculate the cos theta value. So by using this right angle triangle AOP. So triangle AOP. So here R, so here A, so here square root of R square plus A square. So cos theta is equal to adjacent side. So this means A divided by hypotenuse. So A divided by square root of R square plus A square. So this is the value of cos theta. So by using AOP, so right angle triangle, so cos theta is equal to, so this is opposite, this is adjacent, this is hypotenuse. Adjacent side by hypotenuse. So cos theta is equal to A divided by square root of R square plus A square. So now substitute the value. So E is equal to 2E. So what is the value? 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught Q divided by R square plus A square. So next cos theta. So cos theta value is A divided by square root of R square plus A square. So R square plus A square. So E is equal to 2 into E. So equal magnitude. So E1 is equal to E2 is equal to E. So 1 by 4 by epsilon naught Q by R square plus A square into A divided by square root of R square plus A square. So next one. So E is equal to, so in this equation 1 by 4 pi epsilon naught. So Q into 2A. So 2QA, it can be written as Q into 2A. So Q into 2A divided by, so R square plus A square into R square plus A square whole to the power of 1 by 2. So root of R square plus A square, it can be written as R square plus A square whole to the power of 1 by 12. So here also R square plus A square. So R square plus A square into R square plus A square whole to the power of 1 by 2. So this is equal to, so A to the power of M into A to the power of N, M into N. So here A to the power of M into A to the power of N. So that is A to the power of M plus N. So 1 plus 1 by 2. So R square plus A square into root of R square plus A square, it can be written as, so R square plus A square whole to the power of 1 plus 1 by 2. So 1 plus 1 by 2. Next one. Next one. Next one. So here Q into 2A. So we know that Q into 2A is equal to P. So E is equal to, so 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught, the value estimate P divided by, so here R square plus A square whole to the power of 3 by 2. So 1 plus 1 by 2 is equal to 3 by 2. So next one. So we know that, so if small r is very greater than A. So small r, for example, now only point use one. So next inline use one. So inline use one. Inline use one. So R value is increasing, but A value very small. So small r is very greater than capital A. So that means so small dipole. So now if we take the small dipole or point dipole, so here r square is very very greater than a, so a square can be neglected. So a square can be neglected. A square can be neglected. So that means a square tends to 0. So a square can be neglected means a square tends to 0. So therefore intensity of the electric field E is equal to, so 1 by 4 pi epsilon naught P divided by R square. So you value 0 it up. So R square whole to the power of 3 by 2. So a square is 0, substitute this equation. So R square whole to the power of 3 by 2. So here 2 cancel. So resultant electric field at point P on the equatorial line. So 1 by 4 pi epsilon naught P divided by R cube. So this is very 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 important. So E is equal to 1 by 4 pi epsilon naught P divided by R cube. So this is the formula for intensity of the electric field due to an equatorial line of electric line. So here, so in this diagram, once observe this diagram. So E1 cos theta, E2 cos theta responsible for the resultant electric field E. So this is E. So resultant electric field is E. So here, so dipole moment. So we know that in what direction that is dipole moment, negative to positive. So this is negative to positive. So this is P bar. So resultant electric field is E. So this is E direction. So dipole moment is in the opposite direction of the resultant electric field. So dipole moment direction is in the opposite direction of the resultant electric field. Okay. So axial line may line the electric field direction, resultant electric field dipole moment are in same direction. But equatorial line, so dipole moment direction is negative to positive. So resultant is positive to negative. So positive to negative. So this is the final equation. So in this equation it can be also written as E is equal to minus 4 pi epsilon naught P divided by R cube. So here negative sign is indicates that intensity of the electric field is in the opposite direction of the dipole moment. So intensity of the electric field is in the opposite direction of the dipole moment. So this is the very important question from your mind. So these two questions are very important for your board exams. So keep on your mind. So thank you. So in next class we are going to discuss another topics.